Hey everybody, welcome to chemistry lesson 4.05, Introduction to Electron Location. In this video, we're going to begin to describe where the electrons are and how we quantify and qualify them. And we're going to start off with another analogy. So electrons are a lot like you in that they all have an address. The Schrodinger equation provides a set of four numbers. And those four numbers relate to the electron's probable location to the nucleus. So to give you an example, we're going to talk about it in terms of addresses. So let's say I have the school here. So this is us, the school. We have Columbus Grove is the closest town. So here's Grove. And then a little further away, I go to Vaughnsville. U-G-H, Vaughnsville. And then a little further out, I have Kalida. And let's say we're talking about now. So this, before I talk about what these mean and what they translate to, let's say we have one type of building in Grove. We have houses. So we have our building type. And here's the thing, I know this isn't true, but what we're going to say is that every building can hold two people. Two people. Those are people. Those dots represent people. Well, you come a little bit further away and you come to Vaughnsville. Vaughnsville also has houses. But let's say that Vaughnsville also has an apartment building. I don't know if they actually do. And that apartment building has 3 floors. So we've got 2 people in the house, and then each of the floors of the apartment building can hold 2 people. And then we come out a little further to Kalida, and Kalida has 3 building types. Kalida has houses. Kalida has apartment buildings and apartment building. And Kalida has something else. They have a nursing home over there called the Meadows, and it's made up in wings. And so I'm going to try to draw this in wings the best I can. And people live down the wings. And so let's say the Kalida Meadows has 5 wings. Well, each of these, again, 2 people per floor, per wing. So as we get further away from the school, things get a little more complicated. Well, an atom is the same way, except instead of starting at the school, we're going to start at the nucleus. And we come out a little ways from the nucleus, and instead of a town, we have this writing, n equals 1. So in our analogy, we're going to call these, let me draw all 3 of these out, actually. I'm going to have n equals 1, n equals 2, and n equals 3. We're going to call these are the, let me pick light green. So the n equals 1, n equals 2, n equals 3. In our analogy, our town is proportional or the same as our main energy level. The main energy level is the distance from the nucleus. When I'm out at n equals 1, in Grove we said we have 1 building type. At n equals 1, I have 1 orbital shape. So my building type do these in the colors. My building type correlates to the orbital shape. So this, remember that probability map? This is an orbital. And we call the orbitals our sublevels. Our sublevels. When I come out to the second main energy level from the nucleus, I have that circle orbital again, but I also have, and I'm going to draw three 3D axes. Oh, and by the way, each orbital can hold 2 electrons. Each orbital can hold 2 electrons. So the shape that I have for the next orbital is a little unique. It looks like a dumbbell. And I've got 3 of those, but they all turn in different directions. So this is around the z-axis, this is around the x-axis, and this is around the y-axis. That's like my apartment building has 3 floors. The n equals 2 main energy level has 3 p orbitals, and each one of these can hold, guess what, 2 electrons. All right, then I get to n equals 3. Okay, so I've got my sphere again. I'm going to draw all my p's together. It gets kind of messy when you draw them all together, so that's why I wanted to show you to them separately. Oh, and we forgot to write the location in the building correlates to the orbital orientation. So just like here, I could be on floor 1, floor 2, or floor 3, but these are all in the apartment building. These are all what we're going to learn are called p orbitals, but I could be turned around the z-axis, the x-axis, the x-axis, or the y-axis. So again, each of these holds 2 electrons. But now when I get out to n equals 3, the third main energy level, I get an orbital that looks like this. And I can turn this 5 ways. I mean, I have 5 of these turned different ways. Now, I'm not going to try to draw out all 5. But even though there's 4 circles here, these are just a probability. It's like whack-a-mole. You still are only going to have 2 electrons that show up here. So I have 5 of these turned different ways. And this is the way that electrons arrange themselves around the nucleus. So the first 2 electrons, the ones that are in the first main energy level, always show up around the nucleus in a sphere. When I come out a little further, I have some that are in a sphere, but I have some that show up back and forth along this P map. I have some that come this way, I have some that come this way. When I come out a little further, the further out we come, the more complicated we get. So the main energy level is our distance from the nucleus, and we're only going to talk about in this chapter n equals 1, n equals 2, n equals 3. The sublevels, so another term that we should define are sublevels. Those are the total number of orbitals in a main energy level? So here at n equals 1, I have one sublevel. Main energy level 1. Here at main energy level 2, I have got 4 sublevels. Here at main energy level 3, I've got 1, 2, 3, 4, and then I have all 5 of these, so I have 9 sublevels. Keep in mind that each sublevel, so we're talking about orbitals. When we say sublevel, we're talking about orbitals. So I've got 1 orbital, 4 orbitals, 9 orbitals. Each orbital can hold 2 electrons. So what's the total number of electrons that I can have at n equals 1? It's 2. At n equals 2, I have 2, 4, 6, 8. So how many am I going to be able to have at n equals 3? Well, I've got 2, 4, 6, 8, 10, 12, 13. So we have 5 of these, remember? So if we counted it that way, we'd have 10, 12, 14, 16, 18. So at n equals 3, we can have a total of 18 electrons. At n equals 2, we can have a total of 8 electrons. Here we can have 2 electrons. Now we're going to talk about each of these in a lot more detail, but I wanted to give you an analogy of what this is like. So we're talking about town as the main energy level, to sum it up. We're talking about building shape that represents orbital shape. We're talking about location in the building to represent orbital orientation. And then there's a 4th number that we'll talk about later. If you're still a little bit confused after this video, that's okay, because we're going to deal with each of these in more detail. But your takeaways, what you should be able to do is to understand the definition of main energy level, understand the definition of sublevel, and hopefully take away kind of a general understanding from this analogy. All right, that's all we've got for now. Thanks for watching. Have a good one.